A little bit about me. I'm Patrick. I've been working for Snowflake for 3.5 years. So this has got all Snowflake symbols on it because this is an actual implementation that I worked with the customer for about 1.5 years. I learned a lot working with these guys. Basically, these guys were really into data mesh and domain-driven design, and even had the consultancy ThoughtWorks working alongside with them, which I'll get into the details. So just a summary of what I'll cover. Basically, just to set the scene, a customer journey, what it is how the customer got to the position of one, adopting a data vault, and two, making it work with the data mesh and their kind of thinking. Me working in the professional services within Snowflake, we work with a variety of different customers, but particularly a customer like this one, we like to use, I do have lots of quotes in my slide deck. Purposeful strategy for your data mesh or your data architecture really matters, really involves a lot of planning. So, when I joined this customer, it wasn't right away in the beginning. However, we did spend a lot of time designing, basically collaborating, me learning from these guys, and I'm providing the service that I do with knowledge on Snowflake as well as data vaults, which we'll get into as well. What I'd like to start off this journey or the slide deck is also to quote Zhamak Dehghani. So as a lot of people know, or a lot of you guys know, data mesh isn't anything to do with technology. It's basically how an organization is structured around technology, or how they're prepared to adopt a different kind of decentralized thinking of analytics or data, as you will. But I will say that data mesh borrows heavily from two other concepts. The first being Eric Evans' domain-driven design, which is a large part or the cornerstone of data mesh. And data mesh also borrows heavily from Matthew Skelton's team topologies, which is really a way of organizing teams that are stream-aligned. And stream-aligned means that these teams are basically become experts of the domains that they're aligned with, which is something that I'll also discuss in a further slide. So the customer that I worked with is data-driven, software heavy. They they like to write their own software or custom-built software. And being quite ambitious, they started off on-prem and building out their whole software architecture, and found the need to start analyzing that data. And like a lot of newish companies to the data-driven mindset, they started off with building a data warehouse based on SQL Server on-premise. So a lot of challenges came up as the company was ambitiously growing. I can't mention who they are, but I can say that their use case, or rather their product and services, they automate a lot of things as a service for you, so similar to like Snowflake as a software as a service. And they were seeing a lot of wide-scale adoption. So they made the conscious decision just to migrate what they had on-prem to the cloud. So they did this, and they chose AWS as their preferred cloud service provider. And when they went ahead with this, they picked Redshift at the time. This is many years ago, and started migrating all their content and all their software onto the cloud, and data services on the cloud as well. But they started to find challenges. They love the cloud architecture, obviously, that's the scalability of everything that they do in the cloud. But they found challenges with Redshift itself. So they're a global player, or they expanded globally. They needed to ingest data from global data centers into a central data warehouse, and they were doing this in Redshift. The challenges that they found with using Redshift is that their cost of operating Redshift ran into about $500,000 per year. And with the amount of complexity to manage the data itself, to get the data in, it took about 48 hours to get the data out into BI reporting, into dashboards, into whatever analytics they wanted to do. Which of course is no good for a rapidly growing analytics data-driven corporation. So they also, and as a side note, they also adopted Data Vault back then, but they didn't go ahead and do any training or any sort of purposeful, hiring of a consultancy who does Data Vault for them. Instead, they adopted a tool and they went ahead and read some blogs. So this is how you build Data Vault, and they built a Data Vault with many hubs, lots of links, lots of satellites. Not really sticking to a standard because blogs, as they are published on the internet, could be a variety of flavors of Data Vault, and none of them actually really point out which flavor of Data Vault that they're talking about or they're blogging about. So they found some challenges with the Redshift. So a few years down the track, a new head of data was hired at this company, at this customer, and this guy happened to purchase my book as well, and learned that I was working at Snowflake, and they had consciously decided to already use Snowflake as their data platform. So on LinkedIn, we had a discussion, a chat, and I said, yeah, I'll be happy to help you. Let's make it work. And through commercials and everything, I was onboarded onto their team. They had already been 1 year into the journey of designing the platform and also designing and scoping what they were going to do to enable their global teams to be proficient, not only on Data Vault, on Snowflake, but also the plethora of tools that they POC'd and chose to interact or to integrate to serve their data mesh needs, as well as having the Data Vaults in the middle. That guy, that head of data, is a big fan of Data Vault. He's read a lot of blogs as well. He's also a fan of Dan Lindstedt. So this was an opportune time because he was also based out of Melbourne. So same time zone, and an opportune time or opportunity to help them, or for me to help them on their journey. So just to have a quick slide on what their architecture looked like. A bunch of tools, interoperability, tools chosen for what they're good at. They had Fivetran to pull in the data from global data sources, sharded data sources, and conform that to a single landed table into Snowflake. In fact, the Snowflake account was based out of US. They were also streaming data into Snowflake. At the time, we didn't have a mature streaming Snowpipe capability just yet. So we were using just the regular Snowpipe to ingest the data with the Kafka connector. We were also using, or they were also using Accrual Data Hub as their, let's say, lineage across the software domain, how everything gets into Snowflake itself, all the lineage and all the cataloged information. They chose prefix, and they were also profiling which Data Vault automation package to use. And they settled on, at the time, it was called dbt Vault, which was, of course, renamed as Automate DV. And through that, and through collaboration of my knowledge with Snowflake and working together, we took what was available in the package, adopted it, and of course made little tweaks here and there to make it work for how we wanted to adopt or build our Data Vault on Snowflake. So other data sources also included Google Analytics. So there's a plugin now that you can get the raw analytics out of adverts and clickstream data, but it does require BigQuery, an instance of BigQuery, so that it can scrape the data through there. We were also still replicating data out of Redshift into Snowflake. The big advantage, of course, is when we were doing this, the reporting time was immediately down to 12 hours, And some of the use case, the way that we were architecting them, were actually getting down to 10 minutes. So the data was available in one platform. We didn't need to copy that data out of Redshift into another platform to make it available for analysts to use them. These guys, it's really exciting to work with these guys because they were really keen on adopting and trying new tools and new things. They were early adopters of our Salesforce and Snowflake integration, where you can open tables managed by Snowflake inside Salesforce and vice versa. At the time before I left, we were already exploring and adopting Iceberg as a preferred table format, because that would have opened up a lot more interoperability with the native tools that are outside of Snowflake and perhaps some of the analysts and data teams prefer to use. For example, SageMaker. They weren't really ready to adopt Snowpark or any of the AI tools that Snowflake comes with. They had a preference to using SageMaker, and using something like Iceberg gives you that opportunity to integrate and interoperate between environments. And we had a plethora of tools, of course, to query the data, to analyze the data. We're still using MicroStrategy. We're adopting Streamlit, different ways of consuming the data. Notebooks. Snowflake recently introduced our own notebooks, so you don't have to have an external tool to actually do or use notebooks per se. You can actually do it within Snowflake now. And the last thing I would say about the architecture, that they're really software heavy. So like I said, they love writing their own custom apps, especially microservices, and to support their own customers who are creating apps on their platform as well. So to that end, they also created their own custom catalog. So part of the data mesh thinking is self-service, and in this catalog, you could register data products and know who the owner of that product is. So if there's data that you needed that you know is available somewhere or is supported somewhere, you knew how to contact the domain owner. So you can start a discussion and start finding out a way of getting that data ingested into Snowflake, whether it's event data, batch data, whatever the use case is. So just a caveat, or just a side note, of course, on Snowflake, we don't say you should do Data Vault or you should do Kimball modeling. The platform, of course, supports any data modeling paradigm, but each one does come with their caveats. So as you know, Snowflake does not have indexes in their native tables. So an architecture or data model like a third normal form, where business rules are enforced by foreign keys, mostly, you have to build that into a pipeline. Whereas Data Vault and Kimball, of course, is much easier to do, and it implies, because it is a very limited number of or types of tables, it implies repeatable patterns to adopt these modeling paradigms, and of course run those test suites after you've loaded the data. So to the Data Vault and how we adopted it. So to start this part off, I'll begin with the quote from Dan Lindstedt on what a data vault is. It is a system of business intelligence containing the necessary components needed to accomplish enterprise vision in data warehousing and information delivery. The important two words for me in here is obviously highlighted already, is enterprise vision, because a data vault shouldn't be just adopted just because you want to build hubs, links, and satellites. It should actually represent the business architecture, or the top-down view of what the business looks like, how it operates, and so on. So there's a really good blog written by John Giles, who's also Melbourne-based, called Top-Down Modeling, which I recommend reading, where it emphasizes the idea that really when you're building your data vault, that you're considering the business architecture or business ontology or some sort of taxonomy that drives what those hub keys look like, at least from the hub keys perspective. So when I joined this customer, I had worked for a Data Vault consulting before. One of the first things that I was looking for is whether this customer had a business architecture practice or a business ontology practice, as in what I think is called these days a knowledge engineering practice where we divide a company between what it does and how it does things and how we track business objects per se, because that's what I really wanted to base the data vault on and help the teams adopt this way of thinking and make it realized into their information domain. And luckily for me, like I said earlier, they're really into domain-driven design through their software architecture and adopting a way of data mesh thinking as well. So they have this practice, this sort of knowledge engineering practice, and because of this, because of they hired or they collaborated with ThoughtWorks, who are really the consultancy out there that's pushing domain-driven design and the way to build microservices architecture. In fact, Zhamak Dagani is an ex-ThoughtWorks employee. So is Martin Fowler, and they purposely push the idea of domain-driven design where the software looks or represents the automation of business processes and the business processes that are used to support their domains, right? The domains of their company. So they hired these guys to come in to also do something called domain mapping. And domain mapping is basically breaking up their software architecture into three subdomains, which is core, software domain, the supporting, and generic. Core is obviously more customer facing, more high value, and it's also the basis of what we need or the capabilities that we need to ingest it into our Snowflake or our analytics domain, because it's going to be dealing with things that are more or less customer facing. Now, the thing about domain or domain mapping rather, it's similar to what we look for in business architecture. So in business architecture space, which is the first layer of enterprise architecture, we break up a business into business capabilities. And those capabilities are core, strategic, and generic. Core being more customer facing, right? So in business architecture, the four main knowledge areas are capabilities, value streams, business unit or organization, and information mapping. So a business capability is what the business does, this capability or that capability or whatever. And every single business capability is based on at least one business object. So in this example here, if I was to look at policy management, we're managing policy as a business object, case management, a case, product, user management, and so on. Each capability is enabling at least one value stream stage. Value streams are how a business delivers value, right? So you'd have something triggering a triggering stakeholder that triggers a value stream, and there'd be steps along the way, which are value stream stages that takes you to some sort of value at the end of it, whether it's the same stakeholder or other stakeholders, customers or partners or so on. It's how a business operates or delivers value rather. So business units are more or less one-to-one with business capabilities. So somebody is owning the capability, and information mapping realizes those business objects. So it realizes business objects through the data domain or information systems, right? So any business, whatever industry it's in, whether it's financial services or manufacturing or healthcare, are always looking for three things out of their data, right? So I said business capability is always based on at least one business object, but how do we identify it? How do we describe it? It's a business key for sure. What uniquely identifies this business object to the entire business? The description is the information mapping, aliases, how you describe that business object. In business architecture speak, it's called information mapping, but it's synonymous with a business glossary, really. So the second thing that we're really after about business objects is what other business objects is this object related to interacting with through business events or transactions or whatever. What is the recorded interaction between these business objects? And the last thing that we want to track about business objects as well as the interactions, relationships, is the state information of those objects and relationships. what's the name, surname, what type of product it is, whether it's a finite state or a free text state, which could be anything. And we track this against the transactions as well as the business objects itself, right? So if you cast your mind back to the software domain is nothing more than automation engines for your business processes, right? A business process can actually go across value streams and across business capabilities because it's not just start and end in one business unit. Business process can involve multiple capabilities in multiple business units, and a single business process can actually be reused across value streams and capabilities. The automation of these business processes are usually supported by software, either custom built or off-the-shelf software that a particular vendor does these business processes better than anybody else, and it's more feasible to use their software off the shelf to automate these business processes. All these softwares, all this automation is capturing state about business objects, about interactions, transactions, and that state information is what we want out of that microservices domain, in our case, out of the software architecture and sucked into our Snowflake or analytics platform, which falls under the producer domain. So these software is emitting data. And through a data contract, we negotiate what we need out of those software, out of that software domain. So the way we adopted data mesh thinking is that we were constructing this single Snowflake accounts, because there's obviously different ways you can do data mesh, including different implementations of data mesh using Snowflake, where you could have multiple accounts and you have data sharing between Snowflake accounts. Or the way we've done it is have a single Snowflake account and actually divide the domains between databases, right? The thinking behind why we adopted it this way instead of having separate accounts is because having separate accounts means a replication of logic, of software, of costs, of licenses, and so on. So instead of doing that, we wanted a single place where data is brought together, which is our aggregate domain, our data vault. So we take the data out of the producer domain, model it into a raw vault as hubs, links, and satellites. And if there were gaps between what was available in the software and what we needed as business cases, perhaps we created, actually the first case is we go to the software domain and figure out if they can, build this change, because that's the best place to do it. Or if it's not feasible to do it, then we possibly have to either solve it in pre-staging if it's a small fix, or have to model something as an extension of raw vault, build business vault links and satellites, right? The way we adopted business vault in our interpretation is that it's a physical table that uses the same auditability as raw vault. So they were physical tables that had applied date, load dates, record source, and the works. And to the very right-hand side of the architecture is our consumer domain. So each domain had their own database with a default set of schema, but they were free to create their own schema, which each schema could be used as a container for artifacts that they need for their own engagement data products. So it's a funny way of saying just, tables and architecture used to support things like dashboards or extracts or whatever they needed on that side. But you could have a mix of, marketing, finance, and whatever, who are using the data vaults, who are using the raw vault and business vault, which is, we had a shared area, and we had, by extension, each schema had their own private business vault area as well. We didn't force everybody to actually go through the vault to deliver their business case all the way through to the consumer domain. If a user just needed to suck in the producer domain data, they're free to do so. But if they wanted to inherit the maturity that we're building with this platform, which meant repeatable patterns and templates and so on, then we encourage them to adopt a data vault, which I'll get into shortly. It really meant that we were building, at least when I joined, I was working with a team locally, the first team chosen to start adopting the way we're going to build our data vault. And this, what we called it, was our data vault path to glory. So with this first team, basically the strategy really involved people, of course, because we had teams globally. So we started with a team locally here who got trained on Data Vault, and I worked closely with as a Data Vault coach. So in that first couple of iterations, we developed ways of working as an agile company does. How we do business concept modeling, questionnaires on how to decide what's a business key, how to profile data, provided flow charts and so on, how we identify business keys, how we go about doing mob modeling. So basically, tapping the SME and having like a 1 or 2 hour session on figuring out how it is that we're going to model the content. We also adopted Steel Thread, Data Vault's body of knowledge, this naming standards, of course. But by far the most successful artifact that we built or deployed is the adoption of Steve Hoberman's data modeling scorecard. So we took that concept and adapted it for Data Vault. So we took it as is and changed it here and there to make it work for us. And the feedback was awesome, really, because we had different engineers. They weren't modelers per se, but they were asked to model a Data Vault. So through the use of the flow charts and the questionnaires and the model scorecard, it wasn't just about scoring a data model, but also used as a guide on how to build a Data Vault model, which they said is like that. This is awesome. We love it. It really accelerated everyone to sort of be on the same page on how we deliver a Data Vault. And as we adopted this, as we built this out, it wasn't completely a dictatorship, but we made it work for the global team. The idea, of course, was to be building towards a single enterprise Data Vault model, right? So we started, like I said, with a team out in Australia, but every 6 months, new teams were trained on Data Vault 2.0. And then I had to get onto calls early in the morning, late in the evening to help these guys scale up into the artifacts we built. Even how we're using automate DV, DBT, pit tables, and so on, because we were trying to enforce, not strictly enforce, but at least have some sort of governance on how we're building a global data vault, really. And this is kind of where the line sort of crosses over to data mesh thinking. As I said earlier, data mesh borrows heavily from team topologies, Matthew Skelton's team topologies, which basically they talk about how they structure teams around domains, which is the stream-aligned teams, infrastructure team that supports everybody, that's not really involved in the business cases and so on. But we acted as an enabling team for the other teams that were onboarded onto the Data Vault platform. So as we're building things out, as it was scaling out as horizontally and more use cases coming in, we were enabling global teams out of US, out of UK, out of Canada, out of New Zealand as well, and reusing this sort of team topologies sort of way of thinking. Now, why is it that we have these stream-aligned teams? Why is it that we have, these teams are particularly aligned to particular domains as part of the business? It's really the same lesson that was learned in domain-driven design all those years ago. And, well, actually, before I get that, let me speak about strategic design. So strategic design is out of the domain-driven design book. It discusses context mapping. So basically how software is managed between software itself and teams managing that software as well. So for our data mesh, although the team or the company as a whole adopted 5 of those context mappings, so separate ways, partnership models is really about the interactions between the software itself. So separate ways says, okay, there's copies of the same software because each team has a specific need, and the if they were to work on the same piece of microservices, that perhaps they would impede each other. As part of the data mesh thinking, we did not adopt the first two, but we definitely adopted the next three. So customer supply is exactly that interaction between the producer domain and us being consumers of that producer data. So we tap that software, which is more often than not is a custom software, and the domain owner, and have this interaction of, what we need, how do we get it, how do we understand the data, and what shape or form can we get it into the Snowflake platform. A conformist context map is, where we are interacting with either a vendor software where we can't change really, we just have to adopt what they push. Usually, I mean, of course, software of that nature is only really purchased because it automates all or part of a business process that we need anyway. And the last is anti-corruption layer. If we're ingesting data from a source that, let's say, is legacy and it's too complicated to change, then perhaps a layer of views or something that doesn't corrupt our data or brings the data into the form that we need into the platform. So these domain-driven design and the concept and context mapping as well was new to me. While I was working with them, I read Eric Evans' book, and in the context of at least helping the team and delivering with them and speaking their language, I suggested that we should bring another context map into our data mesh thinking, and that's called the shared kernel. So remember the words shared kernel, it'll come up later in later slides. It was introduced for a particular use case, which we'll get to. So what I was saying earlier, why do we have these stream-aligned teams? Why do we have particular domains that are focused on parts of the business that really tries to understand how the data works or how the business is being delivered or automated by that software? Because it's the same lesson that we learned, or domain-driven design learned all those years ago, is that there's not domain experts' knowledge that goes into production, is an assumption of developers. And in our case, it's the modelers, right? So we spent time with, of course, the source domains to understand how it works, because we needed to align as close as possible how the data looks like in the source to get it into the form that we need. So the form that we need, of course, we're building Data Vault's enterprise model, split into hubs, links, and satellites. Business objects with their business keys, relationships, interactions, and links, and satellites capturing the state information of those hubs and links. Hub satellites, links, satellites, right? Of course, the beauty of building a data vault is if they only have 3 table types, it implies that there's only 3 ingestion types. So we had hub loaders, link loaders, and satellite loaders. So it didn't really matter what the source data looks like, whether it was JSON or structured, semi-structured, unstructured XML. And lately, we can actually also ingest PDF content as well. What the outcome is hubs, links, and satellites, business objects, relationships, interactions, and the state information of that. So what I said earlier is teams didn't have to use our Data Vault automation, but if they chose to, they inherited a lot of the maturity we built in. And one of those is the test suite. So I have a GitHub repo that's public with a test suite that they adopted as well, because it's a repeatable pattern. So looking for duplicates after load, reconciliation between artifacts, and checking, record counts and making sure that the data in staging made it all the way to the Data Vault itself. The beauty of these packages is that the outcome of it is lookup tables that you can, plonk dashboards on top and look at the metrics and see if everything's good. Because obviously we don't have primary keys and referential integrity enforced in Snowflake. So teams were building out their models, their context, and basically, the pipelines would simply look like this. New data was being ingested. We were adopting streams in Snowflake. So it's really just a offset on the table. So that's what that orange arrow is depicting. That, if you create a stream on an object, it's really like a a watermark, a bookmark of the last time you ingested data into a target table. So we mix that up with a framework with Automate DV. So, the beauty of building a data vault model, of course, is it doesn't really matter how complex your model looks like. All the tables will be loaded in parallel, right? Because we adopted hash keys. I think we used SHA-1. You can for sure do it without hash keys using just natural key loads. It would be faster, but there are pros and cons to either adopting hash keys or using natural key data vaults. And our use cases can also be a little more complicated, where we load into the same hub table, right? A limitation with DBT is that each target table is only configurable per .sql file, which unfortunately on a data vault automation package, it meant that a single hub table.sql has a union all across different sources. Not great. I'd love it to actually find some way to have independent loads to the same hub table and change that into a merge statement instead. And a merge in Snowflake locks the table without erroring. So it won't have two threads trying to load the same hub table at the same time, which you could end up with duplicates. It actually, in the background, locks the table and the thread waits, releases it, and the second thread will then populate that table. So, of course, with multiple teams building their own data vault models, so to speak, our goal is passive integration. And passive integration in the data vault is integration by business key on the data vault. And that is where we talk about a shared kernel. So that context mapping in domain-driven design is talking about particularly for software, a piece of microservice or software that has heavy collaboration between teams. We adopted that same thinking on how we're managing our hub tables because they ultimately represent our top-down model of business architecture. So that meant that the hub tables themselves, we were governing them. In other words, we know what our business architecture looks like, our domain architecture. So we more or less know what hub tables there should exist. And if our use case suggests that it's loading a new hub table, then why? What is it? Is it a new capability, or is it new business object within the capability? We needed to know, right? The other cases, of course, is managing what goes into the hub table. And we identified three main ways of managing the business keys in the hub table. Either there's natural passive integration, or there is a mapping between contexts, or we have to manage collisions. So what that meant is that, let's say a single business object has the same business key in multiple software sources. So if you load into the same hub table, they would naturally passively integrate. So source context 1, source context B would load to the same hub table record. If a single business object has different business keys, which can happen between different software contexts, then one of those sources or another source has to supply a mapping between the two. I worked at a different customer where this was the case when we were using master data management as a source, because we were collapsing business keys to a match merge key across source systems. And the way we did that is that we had the MDM supply us with the different source keys mapped to a match merge key, which was then loaded to the same hub table. And the last case is let's say that the same business key actually, or value or similar profile, represents different business objects across contexts. Then one of those objects should have a collision code. So it breaks up the record into that hub table and ensures we're not joining data that's not related, right? As an example, natural passive integration, key 101, easy. Where there's a mapping, you have two records, you need a same as link or something that maps the one key to the other. You also need to decide which business key is what the business wants to see or report on. So one of those keys, let's say it's 101, is what actually gets presented in the consumption domain. And then the last one, you'd introduce a collision code, right? The hub table by itself always has a collision code column. It never defaults to the source value, because otherwise you'd have so many records and lots of same as links just to resolve something of a technical debt that you introduced yourself. only when you need to use a collision code do you introduce the collision code concept, right? And this integration between multiple software domains and the information landscape is such an important concept within data warehousing that, in fact, Bill Inman changed his definition of what a data warehouse is by including the words by business key. So everything else in the definition is the same, time variant, non-volatile, and so on. But the business key is really the integration point for all your data model artifacts, right? So, of course, it's not just a little model like that. As we bring in more use cases, we're bringing more satellites. I convinced them not to use multi-axis satellites right away because it implies a certain way of loading. Instead, we adopted satellites with dependent child keys, which gave us a finer grain true change capture for each record. The dependent child key is not a business object, so therefore we inserted it into the satellite table itself. We definitely expanded PIT code. We evolved the PIT code that comes out of the usual data vault training and manuals. And that's because we found a way to make it faster. We turned a 28-minute load or PIT table rebuild into 2 minutes. And I published a blog as well with the code that actually did it and deployed it as a dynamic table. So the first time it'll be 2 minutes, but every time there's new keys, it'll incrementally update itself. So it's like a per second update. We adopted CPITs, basically a PIT table that only has the active record, because within Snowflake, it helps with Bloom filters to find where the active record is. It's a technique called dynamic pruning. We were definitely using bridge tables. I did demo what an activity schema looks like and how that can be adopted into a data vault. I'm not sure if they adopted it because it was already the end of my tenure with the customer. But we're definitely using a lot of techniques in combination to see what works and ingest the data best for the downstream consumption. I put in there Twine and as of join because I have tested it, and there are specific use cases where this works better than using PIT tables. There's also a blog that I published with the results of using that as well. So there will definitely be lots and lots of hubs and links and satellites and so on in your data vault architecture. So again, the way we adopted data vault for our data mesh is that we're supporting multiple bounded contexts in a single enterprise model. And we also were sparsely modeling business vault entities. So we didn't really care how they expanded their business vault. We did emphasize the separation of code logic and the actual physical data. So you could be doing transformations in Python, Snowpark, SageMaker, or SQL, and that outcome is treated as a source and then modeled into a business vault satellite. As long as it still carries the same applied date, you know which record it came from in terms of the raw vault. Another innovation that I suggested that we adopt, that we did, is I said to the guys, documentation can be a pain. However, Jira documentation in an agile company is mandatory. So for every record, there is a Jira ID column, a DV_Jira ID, which then had the Jira ID, which anybody can reference, and they can find out how that record got there or how that data got there. What was the initiative? What's the documentation that was put together or the tests and so on that got that record into that data set. So, hub tables remain the same. We had expanding use cases, more link tables, more bounded context, and so on, which, independently managed by all these data pipelines. They were exploring whether they should have multi-repo or mono-repo. At the time, I was already leaving, so I'm not sure what they ended up with. In my mind, a multi-repo makes sense. So that you could possibly actually be loading to the same hub table with independent Automate DV loaders, but then you need to make sure that the loaders are following the same naming standards, per se. So just to close it off, because I see there's a bunch of questions coming up, I'll just put some bullets in there. Data Vault's great. It conforms different ways of or different methods of source data, whether it's JSON or structured data, CSV, Parquet, whatever, into the three artifacts that we want, or that are repeatable patterns, hubs, links, and satellites. Definitely do the work to find out if there's a business ontology or not, or at least try to push at a customer to build one. Whether it's a lightweight one like business concept modeling, which is something I did recently at another customer, or if you find somebody you can engage with to find out what those business objects are, because that's really what should drive what your hub tables look like. So when we were building our Data Vault model, everybody who was building it, or all the engineers, were trained in Data Vault. We definitely cared what the hub tables looked like. We didn't so much care what they did or how they built their links and satellites, because they're trained, they've been coached. But the integration points, the shared kernel, was super important. I have published blogs and methods or evidence as well that the tables built in Data Vault does support OLAP capabilities of a platform like Snowflake. So in particular, if you were building Kimball models, for example, one of the things that you go after is a right deep join tree, which is called a hash join. You can definitely replicate that capability using pits and satellites. And more recently, or actually 2-3 years ago, I did publish a blog on SnowPit, which is just sequence number only pit, where I take the auto increment columns out of a satellite and combine that, instead of using the hash keys and load dates, as a pit. And one of the things I want to leave you with as well is that we do want to solve complexity up front. So when I consult with customers, I explain that there's a first, second, and third prize. First prize, if there is technical debt, is it possible to solve it in the source? And we shouldn't be shy to ask that, right? Because the Data Vault is not meant to be the repository of technical debt. So if that cannot be solved there, then you need to profile whether it's solvable in pre-staging, before staging, or whether you need to think about build Business Vault artifacts as extensions of Raw Vault. Business Vault is not just about dealing with technical debt. You definitely want to build repeatable patterns or repeatable structures in there. But of course, the more tables you have, the more tables you have to manage, which we definitely try to keep the Data Vault model as small as possible, but still realize that it will be bigger than, or more tables to manage than, let's say, a third or more form. But the repeatable patterns is there. The repeatable patterns and the non-destructiveness to change. And just to finish off, there's a great metaphor about enterprise architecture. I really like this metaphor from Gregor Hope. Basically, he has a background in finance, and he's an enterprise architect, if you've heard of him. He compares data strategy and the time to actually build out or design a purposeful data strategy as selling options, right? So options is a right to purchase a stock at a future date, but not an obligation. And if you take the time up front, there is a higher cost, obviously, because you're doing all this work to collaborate, to find out what is the best technology or what's the best methodology going forward to deliver value. But paying that price up front, you have a higher outcome at the end, or a much more scalable option in a future date. So the lower the strike price, the future date, the higher the value of the option. I really love this metaphor. I did throw in there, the red line for popcorn analytics, another blog I wrote, where I do like DBT, but I don't like some customers who have built a DBT architecture, or let's say model, huge model, where all it is query-driven modeling. They have a need and they write a SQL, and there's the outcome, and that's the model. Where I've seen customers have or data engineers rather, who are managing 10,000 of these models. I don't know how they really do that, but I see that DBT, at least in the last year or two, have been describing a semantic layer to put on top of it. So to me, that's really just a band-aid of the problem underneath, and that is that doing the architecture, thinking up front what your model should look like, and to realize that value downstream. So just to wrap it up, there's QR codes for a lot of the content I put up there. I'm more active on Medium. The last QR code there is the webinar that I used to deliver globally on techniques and patterns to load content into Snowflake for Data Vault, as well as consumption patterns, where I discuss things like it's called join filter in your query plan, but it's really a Bloom filter underneath. And of course, talking about things like write deep join trees and all these sort of query patterns. So that's it. That's 1.5 year journey. Open to questions, of course. I saw that there were a bunch. Apologies for joining, right? Should we keep questions until the end? Yes. How many domains capabilities did this customer have? At a customer with more than 60 capabilities, I experienced a lot of overhead, difficulty with data ownership. Yeah, so I mean, it varies. I remember sitting with actually trawling through some of their Confluence pages, learning how they do things, as you do as a consultant, and ThoughtWorks were comparing this customer's domain map with another customer's domain map. And this one in particular was large, whereas another customer of theirs, I won't go into naming their customers, that's their business, was a lot smaller. And I know at banks, it can get very large with a lot of capabilities. But typically, you have to start somewhere, and it's the I would say, high impact value of business cases. So somebody's going to be funding this data vault or this data architecture initiative, right? And a lot of the time, business don't care what you're doing, as long as it's automated, delivers value, and we're seeing results. So for a head of data, they have to convince business to give them money to do this initiative. And typically they'll choose a business case, a high valued business case. So for that, we just pick one or two capabilities where this value stream or business process is touching, and that's what we start with. It's not boil the ocean. Data Vault is never boil the ocean, but at least you have indication of what their capabilities look like. With 60 capabilities, you definitely won't be doing that at the same time. I hear you overhead, but it's really a political game. You probably know that. Where maybe the first couple of business cases is easy to get in, but I'll quote something that another customer said. You start building this capability, you start proving value, you make the other business owners jealous of what you're delivering. And then they might start to get more open to bring their use cases through this architecture. But you would still not be selling Data Vault to them because they don't care. But you'd be selling the value that you got out of building this platform, right? I hope that answers that.
Thank you. Yes.
Sorry?
Yes, thank you for the answer.
Oh, yeah. Could we use BKC as concat on? I don't recommend it. Should be a separate column, because the moment you start to manipulate business keys, that means the consumption of those keys need to unconcatenate that, right? And one hub table being the intersection of many business keys, you have to decide, which one do I do with what? So each key you need to now split. So you would definitely have its own column. A tip on business key collision code is it needs to be blank and not null, because hashing a null will break hashing digests. So it should be a blank if there's, or just give it a value, say default or something. That's definitely usable. But yes, it must be a separate column. Can you share that GitHub link? Oh yeah, it's already shared.
I linked it, yeah.
Yeah, it's in the state that it is. The intention is that any customer who uses that do the effort to parameterize how they want to parameterize it. There's a lot more columns in there that maybe some that you will not need. One thing I do talk about, especially in the 2-hour webinar, is that I also track distinct values, and in Snowflake, distinct values isn't free. Just counts are free because it's a metadata operation. Snowflake doesn't know what's the distinct values. It doesn't know anything about the values inside the data itself. So it would have to actually execute on a warehouse to find out what that number is, virtual warehouse. What do you do if data from the operational system doesn't map nicely onto the business ontology, for example, totally aligned between the two worlds? Well, why did that business buy that software? Let's start with that. It has to. If it doesn't, then what is that software doing there? There must be some mapping, some use case of that software being in place. So when I talk about the software domain as well, it's not things like email servers or stuff, right? That would fall into the generic domain of domain mappings. Like we have this capability, but we're definitely not going to create it ourselves. And it doesn't, we do not use it to automate any of our business processes. So there must be some identifiers there. Now, what I said earlier about the strategic design is perhaps a source system doesn't have that business key or has no capability of having that business key in there. It might be tracking against its own business key. Then we need some sort of mapping. Something must tell us how to get that key into the business key that's representative that the business uses, or maybe even that the customer uses with their interaction with the business. For example, if they got a complaint and a case is raised, you'll have a case identifier. The customer is going to be using that. That's our business key. And if we're using a source system like Pega, there would be a lot of information in there. Like I think it's called Brzezinski and PZID or something like that. But that's our business key, right? There's some more machinations around that. But if you are ingesting software that is not representative of what the business does, then there's a problem. Either there's a capability missing or that software shouldn't be there.
Can I respond? Maybe like a lot of times it's like a timing issue where the current operational systems implement a certain version of the process, but the business architect who makes the ontology, he thinks of like a future vision in mind, which is like more ideal. So that's why usually I see like this where they are unaligned.
Yeah. But somebody needs to make a call on what that is, even if it's because under business architecture, you do something, there's already like capability, and I think that they color coded like gray or something saying, this is coming. We don't have it yet, but it's in our, I don't know, 1 year, 3 year plan.
Yeah.
But it must be there because if one side of the business is purchasing or building software without business sign-off, there's a problem.
Thank you.
Yeah, it actually speaks to our Data Vault is not the repository of technical debt. We have to push back saying somebody needs to take ownership of this. Where is this coming from? What are the business objects? How do we map this to how your business works? Are there plans to share the recording of this meeting? Yeah, I think Alex already answered that. Yep. Thumbs up, very insightful things. How do you ensure that business logic remains consistent across departments? Shared business vault and information layer. I did have that. So the data mesh that we built recognized that we don't want to waste time having very much the same capability built in different accounts, right? And we had databases that were essentially assigned to different business domains, who then inherited all the maturity work that we were building into the single account. There is a good blog, I forget the guy's name, but it's titled something like Data Mesh Topologies. So different ways of thinking about building a data mesh, because as wonderful as the data mesh book is about saying everything should be decentralized, the reality is that there's a cost to doing that. And it's the replication cost, right? And this customer recognized that. I mean, they already decided this is how they're going to do their data mesh before I joined. I came in to help them build a data vault, but I definitely learned why they did these things. And it doesn't look that much different to how you deliver analytics platform anyway. I think what's different is this emphasis on cataloging and data contracts, and you could arguably say data contracts is no different to an interface contract, but there's also there's a blog that I wrote as well that that highlights, there's metadata, there's data quality, and all these components together form what a data contract is, and it's expected by the provider, but it's owned by the consumer, right? Because the consumer knows what data they want, and it's not definitely not everything that a provider is emitting. It's only the core data that's useful to the business, right? That they want. So that's a reason also why the consumer owns a data contract. Another question. Okay, I'm late. How can I get the recording of the below? Okay, the YouTube and 2 new messages. That's it.
So, yeah, was the blog you were talking about data mesh methodologies this one, James Sarah?
Oh, it wasn't James Sarah.
Okay, one looked good anyway. There, I found that one.
He's got a book out with different architectures and stuff. I haven't seen it or read it yet, but there's a data mesh topologies. There is, wouldn't be, there's James Sarah. I think it's this guy. Maybe it's this guy.
Okay, cool.
Yeah, that's the one. Yeah. So the one that we were doing was the hybrid federated mesh. So multiple source domains coming to an aggregate domain, which some say, why call it an aggregate domain? I think it makes sense because we're actually aggregating data across different domains. One of the if I go back to, let's say, this slide over here, we had particular names for each zones. Although it looks like, it really does look like the medallion architecture. Nobody in this company liked that name. I don't either. So they gave it particular names. The first being the curated zone, where content was cleaned, tagged, and masked, and all things before it was actually integrated downstream into an aggregate domain. They called their middle zone the coherent zone, and they had a really, really brilliant logo for it, or let's say a quote for it. A coherent zone is where data has a connected life. That was, which makes the data coherent. That's what they were calling it. And then the intelligent zone was, what do we want out of the aggregate domain? So I really like the way that they split this content up. They also had a knowledge zone, which is basically how they were recording metrics and run times and logging and all that kind of stuff into a knowledge zone, that tracked everything about the different areas of their architecture. We had a split between public business vault and private business vault. Basically, each consumer domain could extend the existing vault with their own business vault links and satellites, with their own managed data that they didn't necessarily want to share with everybody else, because it may perhaps pollute how people interpret what's available in the aggregate domain. So we also supported that.
Okay, no, that's really insightful. Thank you, Patrick. We are at time. We're a little bit over time. There is one last question that Thomas posted. If you we want to do that, and then we'll leave it there.
What is the question? I don't see it.
I can tell you. You triggered me, Patrick, by saying that the consumer owns the data contract. And then I was thinking, in that case, like for one data set, for example, a customer 360 view, you can have like 10 similar, slightly different data contracts around one certain data set. So I was always under the impression it would be easier to have the provider owning the data contract.
It would be easier. They need to the one thing that this customer did was he achieved getting buy-in from the producer domain. So the producer domain is the software, right? So they were tapped on the shoulder and said, "This is the data we need." So yes, you could have multiple consumer based data contracts.
Okay.
Yes.
Thank you.
Because not all data is of equal value, right? There are what's identified as what they call CDEs. What's it called? It's to do with the core data.
Non-functional requirements, for example, would also make a difference.
Critical data elements. That's what it is.
Yeah.
CD.
Okay.
Yeah, that's what it is. because the data will come through, and you know, whether it's an API call or if it's ingested from from a particular source, it would have, especially our streaming data, had a mix of events in it that we didn't care about and had no value. But because it's in JSON, there was no way for us to really split that data, only after it's been consumed. So, you know, like, oh, we don't want these events. It's like, well, you know, what do you want us to do? It's a bit of work for us to change our architecture to suit you. So instead, we just ingested everything, and in the business vault actually split up what those events are, and in some cases materialize those key values to structured columns to make it easier to consume downstream.
Okay. All right. Excellent. Thank you so much, everyone. Thank you very much, Patrick, and spending so much time answering questions in depth. Really appreciate it. We'll leave it there.